Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM MS 2017, problem number 10. The problem says that let x1, x2, x3 be a random sample from a distribution with the probability density function f of x given theta is equals to 1 by theta into e to the minus x by theta if x is positive and 0 otherwise, where theta is greater than 0. Theta is the parameter here. Which of the following estimators of theta has the smallest variance for all theta greater than 0? So basically, we need to find the variance of each of them and see which one of them has the smallest variance. It's a very straightforward problem, right? And you can see that here the random sample has been taken from the exponential distribution. This is the PDF of the exponential distribution with mean equals to theta, right? So here expectation of xi is nothing but theta and variance of xi is equals to theta square. This comes from the theory, very easy to calculate in fact. So if you remember it from the theory, then you don't have to actually find out the expectation and variance explicitly here because the problem is to calculate the variance of these quantities, these statistics. So let's start with the first option, this one, x1 plus 3x2 plus x3 whole divided by 5. So this one says that variance of this thing is equals to 1 by 25 because obviously this 5 comes out as squared. So 1 by 25 into variance of x1 plus 9 into variance of x2. Remember that 3 squares out when it comes out of the variance. So 3 square, that means 9 into variance of x2 plus variance of x3. Now obviously since x1, x2, x3 are IID, right? They are random sample, therefore they follow IID random, IID exponential with mean theta. Therefore all of them, this variance of x1, x2 and x3, all of them are theta square. So 1 by 25 into theta square plus 9 theta square plus theta square, that means 11 theta square by 25. Now this 11 by 25 is nothing but 0.44 into theta square. So this one is having this variance 0.44 into theta square. Now let's start with the next expression. So variance of x1 plus x2 plus 2x3 whole divided by 4, just as the same case, this 4 comes out as squared, so it's 16. So it's 1 by 16 into variance of x1 plus variance of x2 plus 4 into variance of x3 because the 2 gets squared out, right? It gets squared when it comes out of the variance term. So 4 into variance of x3. Again, all of them are theta square, so theta square plus 4 into theta square whole divided by 16. It's nothing but 3 theta square by 8, right? Which is 0.375 into theta square. So the variance of the second expression, the second option is this one. Now for the third, see variance of x1 plus x2 plus x3 whole divided by 3 is nothing but 1 by 9 because again the square term 1 by 9 times variance of x1 plus variance of x2 plus variance of x3, which is theta square by 3, which is nothing but 0.33 into theta square, right? Because 1 by 3 is nothing but 0.33 and so on. And the last term, variance of x1 plus 2x2 plus 3x3 whole divided by 6 is equals to 1 by 36 into variance of x1 plus 4 into variance of x2 plus 9 into variance of x3, which is nothing but 1 by 36 theta square plus 4 theta square plus 9 theta square is equals to 7 theta square by 18, which is nothing but 0.388. Now, here clearly variance of this thing is the smallest. Why? Because obviously the theta squares are the same, right? These coefficients of the theta squares are the changing ones. They are the changing. So in here 0.33 is the smallest because here it's 0.388, right? Which is greater than 0.33, right? And similarly here it is 0.375, which is also greater than zero point 0.3, and here 0.44, which is also greater than 0.33, right? So every one of them have greater variance than this one. So variance of this expression is the smallest, right? So x1 plus x2 plus x3 whole divided by 3 is that means the sample variance has the smallest, sorry, the sample mean, this quantity is the sample mean, right? X bar. So the sample mean has the smallest variance. So here the option is this one. See, you can also this problem in fact could have also been done without any calculation at all because all of them are actually linear unbiased estimators. See, all of them are nothing but linear unbiased estimators of theta. Each one of them are unbiased estimators of theta, right? And they are linear in nature. So we know that the best linear unbiased estimator is the sample mean, right? So from there we can immediately see that the sample mean, since it is the blue, that means the best linear unbiased estimator. So it will always have the smallest variance. So here, without any calculation, in fact, we can this problem. We can easily solve this problem. But I have just shown the more general one of calculating the variance and stuff. So yeah, there you have it, the solution to this problem. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.